Good morning, students. Today we'll discuss lecture 3 of the same chapter, computer networks. The topic that we are going to discuss today will be network topology. What is network topology? Network topology is the way or the layout or the pattern of the connection of nodes so that they are able to transfer, share information among themselves. Now, this layout also determines what will be the route of flow of information within the network. Now, there are many types of topologies prevalent nowadays, but the most commonly used topologies are bus topology, star topology, ring topology, and tree topology. Now, the bus topology. Bus topology is also known as a linear bus topology, in which a single wire is running through whole of the network and all the nodes are connected to this single wire, and on the either end of the this wire we have nodes, servers, and other devices that are peripherals. Now, a single transmission medium onto which various nodes are attached. There is only and only a single wire which are connected to create this network. Now, because there could be multiple nodes which are connected in this network, therefore only a wire which could carry large amount of data with a very fast speed can be used. Therefore, normally the wire which is used for this type of network is the coaxial cable. In this topology, terminators are used at both the ends, the initial end and the destination end. That means where the network is ending. Terminators are special devices to absorb the signals from going further, or the bandwidth going down. Therefore, the bus topology is a linear way of uh, architecturing a network. Now, there are several advantages of the bus topology. The very first thing is the main advantage, the best advantage of this topology is that it is very easy to expand and very easy to design and develop. In the bus topology, only you need to span a single wire through whole of the network, and all the systems can be connected to each other with the help of these wires. Now, because there is a single wire for any number of nodes, therefore the cost of wire or the total length of wire that is used is quite less. Now, there are some disadvantages apart from the advantages of the bus topology. The first disadvantage of bus topology is that the entire network shuts down if there is a break in the main cable. Now, if by chance, in any case, if the main cable of the topology start malfunctioning, then the whole network is down. That means all of the nodes following the breakage, which are after the breakage from the point where you are experiencing some problem, then the whole network becomes down. Now, terminators are required at both ends of the backbone cable. Now, as we have studied that at the starting and the end point of the network, we need to install a special device known as terminators. So there is an extra expense of installing terminators at both the ends. Now, difficult to identify problem if the entire network shuts down. Now, if the network uh, shuts down all of a sudden, then it is very difficult to identify or diagnose where the problem actually persists. Now, when we are connected to a bus network, then the server is located at one end, and followed by the server are the nodes. So when a server sends a message or an information to a node, then it is the node should be intelligent enough to identify where the or to which node the information is being sent. Therefore, the nodes are required to be very intelligent. Now, star topology. Star topology is another sort of topology. As you can see in the picture, the star topology is used where one server is connected directly to all the nodes which are included in the LAN. So star topology is designed with each node connected directly to a central network hub or concentrator. That means, as I told you, the server is connected to each node directly. That means a single, a separate piece of wire is used to connect each node directly to a server through a device known as hub. Now, data on the star network passes through the hub before continuing to its destination. Now, every data which needs to be transported or transmitted to some other node or the server has to pass through the hub. No data can be bypassed through hub and reach delivered to some other node. The hub manages and control all functions of the network. The hub is responsible to manage and control all the functionality of the network. Secondly, this hub is also responsible to amplify, to upgrade the quality of signals which are traveling in the network to maintain its quality and speed. Now, the advantages of star topology. The very first advantage of star topology is easy to install and wire. Now, in the star topology, the main advantage, the best advantage of this star topology is that it is very easy to connect or include a new node in the network, because the only hardware it needs is a wire that at one end it is connected to the node and the other end goes to the hub. So you can include any number of systems till your hub permits to connect it to the network. So the installation of new nodes in the network is quite easy in case of star topology. No disruption to the network when connecting or removing device. So while you are connecting new node to the network, or detaching the old nodes due to some fault or some any other reasons, uh, the network is unaffected. You can detach or add the node at any point of time with the network running. No need to halt the network even for a single second. Easy to detect fault and remove parts. So whenever the node is down or is not functioning due to any hardware failure or any other reason, then it is very to detect which node is not functioning, because every node is connected to a single wire, and the node which is not working can be identified separately that it is not working. Now, disadvantage of star topology. The main disadvantage of star topology is that it requires more cable length than linear topology, because you need a separate piece of cable for each and every node, no matter how far it is. Therefore, the requirement of good amount of cable length is is the main drawback of this kind of topology. If the hub fails, in case if the central concentrator or the hub fails, then the whole network is down. So the main drawback with this network is that the hub should be very good and very maintained to keep the network up always. More expensive than linear bus topology because of the cost of concentrators. Now there are individually drawbacks of each and every topology. Now the bus topology, you need to install terminators at both the ends, whereas in the star topology there is an extra expense of installing a hub, a central hub in the network. Next, ring topology. A ring topology, as you can see in the picture, a ring topology is also known as token ring topology. In this topology, it is a sort of topology in which a permit or a right to access the resources is given to every node for a fixed period of time. Whichever node has the token is always is you know has the whole permission to retrieve or access any resource in the network, whereas at that time all the nodes which are not having the token remain idle. In this topology, when a node is trying or uh, uh, when a node sends a message to some other node, then all the other nodes remain idle at that time till an acknowledgement is received by the sending node. When the sending node receives the acknowledgement from the destination node, then only it is able to release the token, and then it passes to the next node. Advantages of ring topology. Now the ring topology is a type of topology in which we have a sort of network uh, with a few number of computers. It is not very suitable where there is a large number of systems that are to be included in the network. So when we have a small network, then we can have a ring topology. Now, no wiring closet is required because it is a peer-to-peer network. That means each system is connected to other system with the help of wire. So no wiring or cabling is required separately. Now, because the cost of wires or the length of wire required in this network is quite less, therefore it is best suitable for optical fibers because of the short cable length firstly, and to maintain the speed and quality of the network, it is recommended that the ring topology should have optical fibers type of cabling. Because of the optical fiber in this, the speed of transmission in this type of network is quite high. Now, the another characteristics of this type of network is that the data travels in a single direction, that is a one-way traffic. So any node, if it wants to send any sort of information, then it delivers the message to the next node rather than the previous node. Even if it has to send the message to the previous node, then also it has to pass the message to the next node, and the next node passes the message to the next node, and there then gradually it reaches to the previous node of the sending node. Now the disadvantage of ring topology. The main disadvantage of ring topology is that if even if one of the node fails, then the whole network is down. That means malfunctioning of a single node, and if any node needs to be detached or separated from the network, the whole network becomes down because of the lack of connectivity between the nodes. Now, as any failure of any node shuts down the whole of the network, it is very difficult to identify actually on which node the fault has occurred. Network reconfiguration is difficult. That means uh, any sort of upgrading the network is very difficult. Upgrading a particular node in the network is difficult because whenever we detach a node for any purpose in the network from the network, then the whole network is down. Therefore, it is very difficult to reconfigure a node or the network. Secondly, expansion of this type of network is not that feasible because for the time period till which you are expanding the network is down. Tree topology. The tree topology combines characteristics of linear. It is a hybrid kind of topology in which the structure is something like a linear bus topology and a star topology. As you can see in the figure, node number 1 is connected to node number 2 and node number 2 is connected to node number 3. This is a linear bus topology type of structure, whereas node number 1 has two number of node number 2, and therefore this type of structure gives you an illusion of the star topology because node number 2, both the node number 2 are directly connected to node number 1, and as you can see further in the hierarchy, node number 3, both the node number 3s are connected directly to node number 2, and node number 2 is in turn connected to node number 1. Therefore, this is a structure of star topology. So therefore, we can say the tree topology is a hierarchy of combination of the linear and star topologies. Now, tree topology allows expansion of existing network and enable schools to configure our network to meet their needs. Now, this topology is very feasible where uh, you know the expansion of network is required after every certain period of time. Secondly, for small organizations, it is very feasible, and the expansion of this type of network is quite easy because without disturbing the previous network, you can expand the network but uh, uh, just by combining the nodes in the current hierarchy. Now, advantages of tree topology, that is point to point wiring for individual segments, as we have studied earlier, also peer to peer network. So this is a kind of peer to peer network where each node is directly connected to its next node. So it is a peer to peer network type of topology. Now, most of the hardware and softwares, they support, they are compatible with this type of topology, so no extra expenditure on having a special hardware or a software configuration for having this type of topology. Disadvantage of this topology, overall length of each segment is limited by type of cabling used. Now the major disadvantage of this topology is that you cannot change the type of cabling that you are using in a network. That means if the current network or the existing network is using an STP cable, then you cannot use a coaxial cable for the new expansion of this network. That means the whole of the cabling of this network should be done with a single type of cable. Another disadvantage of this is then if the backbone line breaks, the entire segment goes down. As we have seen in the figure, if supposingly by chance node number 1 is down, then the whole of the network is down. If node number 2 is down, then all the nodes of all the nodes at the next level and levels coming thereafter are down. So at any level, if the parent node becomes down, then the network following that parent becomes down. So this is again a very difficult problem. Now it is a little bit typical and difficult to configure this type of topology than other topologies, because in other topologies either a single wire is used to connect to the network, or in case of star topologies, because we have a hub in between, so the new node is uh, directly connected to the hub. Or if you want to upgrade some old node, then we can simply detach that node and remove the node and upgrade it. But it is quite difficult in this type of networking. Now, considerations while choosing a topology. Now, whenever we are deciding a network at our organization, then we have to keep in mind certain points. Now, these points are the uh, practical criteria that we should always be concerned with, or even any organization will be concerned with. First of all, money, that is cost of networking. So the first emphasis is on the cost that is incurred to create a network. Now, in this way, we can say if we keep the criteria of cost on the priority, then it is recommended that you have a bus topology, because the bus topology needs only a single wire to create a network. So the most inexpensive, we can say, the topology uh, for a network is the bus topology. Then the length of cable needed. Now secondly, we have to decide how much amount of length is needed, and which type of topology is required. Now if we are having if we are thinking of star topology, the star topology has its own benefits, but the if we have into our consideration that the length of the wiring should not be too much, then we should not have a star topology, rather we should go for a linear topology. Then future growth. The third thing that we need to think is that, are we going to expand our network in near future? If yes, if there is a possibility of expansion of the network, then we should always go for a tree topology or a star topology, because these two topologies, especially the star topology, is the easiest way to expand the network. However, if the expansion is possible and quite possible in the near future, then we must always prefer to have a star topology, because it is very easy to expand and reconfigure a network. Now, cable type. Now, no matter how much length of cable is required, but all cables are priced at different tags. The STP, UTP are a lot cheaper cables. Coaxial is a little expensive, and optical fiber is again expensive, and the wireless technologies are again expensive technologies. So whenever we are using some type of cable, then we need to decide how much bandwidth or the speed of transmission we need, and according to the speed of transmission we should decide what type of cable should be used in the network. Now, network devices. We have uh, many network devices, right from creating LAN to connecting to several other LANs or to a wide area network. So we are going to discuss all these network devices as of now. The very first devices that we used for our domestic purpose also, that is modem. Modem stands for modulation demodulation. Modulation demodulation means converting a type of signal into another type of signal. That is, in our computer network, we convert an analog signal to a digital kind of signals. As we use a cabling sort of network, the cable uses a DC technology, direct current technology, to send the signals, and these signals cannot be interpreted by the computer directly. So we needed a device to convert these electronic signals into digital signals, electrical signals into digital signals, that is electronic signals. Therefore, we use modem. Now, there are two types of modems, internal and external. Now, internal modems are the modems which are placed inside the CPU cabinet and are installed permanently inside the body of the computer. They are permanently connected to the standard equipment, whereas the external modems are the modems which are connected from outside and as per the requirement of the user. External modems are portable also, they can be taken to anywhere and connected, whereas the internal modems cannot be connected anywhere. Now, next thing is RJ45 connector. As we can see in a previous slide, that in the RJ45 connector has a sort of connector which looks alike like a telephone connector. So normally the telephone connector is an RJ11 connector having two wires, whereas the RJ45, that is the registered jack 45 connector, is an 8 pin 8 wire connector. So it is used for LAN purposes. Ethernet card. As we have studied in our very first lecture, the NIU, network interface unit. The network interface unit is the network interface card that is installed inside the computer to connect to a network. It is a mandatory part of network, and every machine needs an uh, network interface unit or the Ethernet card to connect to a network. We can see on the back side of this Ethernet card there is a port which is known as LAN port. The RJ45 connector is used to connect here only at this port, and this is how this this card connects a system to a network with the help of the RJ45 connector with wire. Hub. Now in the star topology, as we have studied, all the nodes are connected or are centralized to a central location known as hub or the concentrator. The hub is a device which is used to accommodate all the connections at one place from the network, and in turn connect them to the main server. So a hub is a device which is used to connect a server to multiple devices at the same time. Now, in a star topology, the hubs are used, whereas in the bus topology, and the ring topology, the hubs are not used. There are two types of hubs. A passive and active hub. The active hub is a type of hub which is used with electricity to amplify the signals which are uh, you know flowing through the hub. That means if the systems are located at distant places, then the quality of signals may deteriorate or degrade. So to maintain the quality of signals, uh, an active hub is used, whereas the passive hub is a type of hub which only uses uh, a technology which is used to connect all these devices together. That is it. Now the hubs comes in three types of connectivity. It supports 8 port, 12 port, and 24 ports. Now these are used in star and ring topology. Now switches. Now switch is an intelligent type of hub. It is same as hub, no difference is there. But the only difference between a hub and a switch is that a switch is able to identify a machine. Now the main disadvantage of having an active or passive hub is that a hub cannot identify a particular node in the network. That means if a server sends a message to a particular node in the network, then the hub transmits this information to all the nodes without identifying the particular node for which the message has been sent. Whereas the switch is able to identify each and every node uniquely. So whenever a message is sent by the server to a particular node, it is able to identify the node separately through its MAC address, which is also known as machine address. Now repeater. Repeater is a device which is used to amplify the signals. Amplification of signal means to maintain or upgrade the quality of signals. As we can see, the systems or the nodes which are connected to the network could be at different places far away, and when the signals are far away due to some resistance and distortions, the signal quality may deteriorate or degrade. Now to maintain these quality of signals, it is very important that uh, there should be a device in between so that the quality of signal is maintained at every stage. Therefore, this uh, thing or this problem can be removed with the help of repeaters. So repeaters are amplifying devices. Bridge. Now bridge is a device which is used to connect different types of networks or LANs, you can say, but having the same protocol. That means the type of cabling which is used. That means if a network is wired, if the networks which are need to be connected, if two LANs are suppose wired, they could be connected with the help of bridge. But another uh, you know clause in this case is that they both should be connected. Uh, they both can be connected if and only if they follow the same topology. That means the type of wire and the type of topologies followed by LANs. All the LANs can be connected with the help of bridge. So LANs having different type of networking, different type of topologies cannot be con- uh, cannot be connected to each other with the help of bridge. For this purpose, we have different devices. Now, bridge in telecommunication network, a bridge is a product that connects a local area network to another local area network that uses the same protocol. As I have told you, that the network cabling and or the type of cabling as well as the type of uh, networking, the type of topology should be same if you want to connect two networks with the help of bridge. You can envision a bridge as being a device that decides whether a message from you to someone else is going to local area network in your building or someone to local area network across the street. So the bridge is used to, you know, a bridge is used to connect two networks which may be far distant with the help of bridge. So uh, provided they follow the same criteria, as I've told above, that they should have a similar type of cabling as well as a similar type of topology. Next device, if the uh, cabling is of different type and the topologies that are followed are different, then we have a special device for that purpose that is known as router. So router is used to connect a different type of cabling. If two LANs are having a different type of cabling and a different type of topologies, then we can connect these LANs with the help of a router. Now, uses of a router. A router can be used to connect local area network to another LAN, a wide area network to another LAN. So the same type of, now see, the type of networking, the type of topology may be different, the type of cabling system can be different, but the type of network should be same in the previous devices. But in this case, uh, sorry, uh, the in this case, the type of cabling, the type of topology could be different, but the type of network should be same. That means if two LANs are having a different type of cabling system, a different type of topologies, then they can be connected with the help of router. Now router transmit data packet through these networks, determine the best path of transmission. Now as you can see, the router is you can see in the picture also that it has both the technologies. You can see the port at the back of the router as well as an antenna for wireless. So you can see very well that it supports both the wired and the wireless technology. So that means if two types of cablings are there, that means wired and unwired or wireless technology is used, then a router can accommodate both of these technologies. Gateway. Now the limitation of a, uh, router is that it cannot connect two types of network. That means it cannot connect a LAN to a MAN, LAN to a WAN to a LAN, and so on. So, what is the device which can be used to connect this? Now, the gateway is a device that is used to connect dissimilar networks. Now, the types of networks, a LAN to WAN is is a type of different type of network. So therefore, there is a device known as gateway which is used to connect these types of networkings. Now, it is an intelligent device which connect a local network or an individual computer to another type of network. It is not a compulsion that you need to be in a network, you need to be in a LAN to connect to some network. Rather, you can be a standalone computer to connect to a particular type of networking, and for this purpose a gateway is used. Generally this gateway device is installed by the ISPs, that is internet service providers, that is the telephony companies from which we take the connections of internet. Now the last slide of our lecture today is the LAN design, general network design process. Now, whenever we are thinking of having a LAN, then what is the process of designing a LAN? So, the process of designing a LAN is, first of all, we have to think, we have to empathize, or what requirements do we have from the LAN, how many numbers of computers are there, what all speed I am going to take, what all devices are to be installed, where the server should be placed. All these things are taken into consideration and written. Then we have to define. Now we have to have a rough map of how the devices will be placed, how much distance they will be having. So we will have all notification of that. Then ideate. Then if there are some changes to be made, some improvements are to be made on the dry thinking of this procedure, then it is discussed with other people. Then we create a prototype of the land. That means we just create a rough structure of the land to test whether it is working or not as the way we are expecting it to, and then test the land, and finally uh, when it is successful and we get the desired results, then only we set up the land procedure. So that is all for today. Thank you very much.